Hi guys, in today's video we're going to take a look at the test for functional groups, looking at the tests for unsaturated hydrocarbons, haloalkanes, the carbonyl group, carboxylic acids and alcohols, planning a synthetic route, looking at synthesis maps, an exam style question, and finally a summary.
The first test we're going to have a look at is a test for an unsaturated hydrocarbon. The reagents we'll use for this test are that we'll add a few drops of bromine water to our suspected unsaturated hydrocarbon and we'll shake. The observation that we'll make if we do indeed have an unsaturated hydrocarbon, so a positive outcome, will be that the bromine water becomes decolorized. We'll see a colour change from orange-brown to colourless. And what's actually happening is that a molecule of bromine adds across the double bond present in our unsaturated hydrocarbon in an addition reaction. And you can see that happening here. We have a molecule of ethene with our double bond forming 1,2-dibromoethane in an addition reaction. So now we've taken a look at the test for unsaturated hydrocarbons, let's take a look at the test for haloalkanes. For this test, we require silver nitrate, ethanol and water. And what we see is that for each of the different haloalkanes, we'll observe a slightly different precipitate forming. With silver chloride, we would expect a white precipitate to form. With our silver bromide, we'd expect a cream precipitate, and with silver iodide, a pale yellow precipitate forming. And what's happening is the halogen atom is displaced as a halide ion. So as you can see from our reaction here, that halide ion then goes on to react with the silver ion from our silver nitrate to form our precipitate of a silver halide. So silver chloride, bromide or iodide. So now I've had a look at the test for our haloalkanes, let's have a look at the group of tests that we can use to identify the presence of a carbonyl group. The reagent we use is acidified potassium dichromate, and the observation we'll make is that with our aldehydes we'll observe a colour change from orange to green, and with our ketones we'll observe no colour change at all. Now what's happening here is the orange solution that contains our dichromate ions is reduced to a green solution containing chromium-3 ions. So the chromium species changes oxidation state from 6 to 3. It is reduced. The second test we can use to test for the presence of our carbonyl group is Tollen's reagent. This is a solution of silver nitrate and ammonia, and the observation we'll make is that with our aldehydes we'll form this silver mirror. A silver mirror will coat the inside of the test tube that you're using if we do indeed have a carbonyl group present.
Hey guys! To continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today and together let's make A-level chemistry a walk in the park.